Hello, and welcome to 5 Minute Math. Today we are looking at the 8th grade concept of Pythagorean Theorem on a coordinate plane. This is standard 8.7D in the great state of Texas, and we are using item number 22 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got these 2 points, K and L. Which measurement is closest to the distance between points K and L? We don't need a ruler here. What we need here is we need to just be able to count the distance. Now, let me tell you what we're not going to do. We're not just going to say 1, 2, 3, 4, 5. We're not going to do that because the distance across a square, these are all little squares. These diagonals are not the same length as one of the side lengths that goes up or down. The diagonal is a little bit longer, so this would be way too easy. So let's not do that. Let's instead think of it like a right triangle, because that's what we work on in the 8th grade. So take a look at this. If I were to draw a line right here, right there, and then I think, okay, so I want to draw a third dot, and then I want to connect that third dot to each of those 2 points, K and L. And I specifically chose this dot here that has the same y value as the L, has the same x value as the K, because I want to create a right angle. Because if I can create a right angle in a right triangle, now I could use, see in our reference material, it's simply labeled right there at the very bottom there, Pythagorean Theorem, a squared plus b squared equals c squared. I can use that here. So what that means is that if I were to draw squares off the back sides of these triangles, right? So I'm going to draw these two squares right here. And literally what this means, if I take these two green squares, it's going to be the exact same area. If you take the sum, and if we're going to kind of go off the screen, that's fine. Those two green squares added together are the exact same area of the blue square. That's what a squared plus b squared equals c squared means. And it happens for every single right triangle. Doesn't matter the side lengths, doesn't matter the sides. If it's a right triangle, it's going to work. So we need to know that when we're dealing with our a squared plus b squared equals c squared, our Pythagorean theorem, these two a and b on the left, those are the legs. So those are the two sides that come off the right angle. So it doesn't matter which one is which. We'll call this one A, call this one B. This C is always across from the right angle. It's always the longest side. It's called the hypotenuse. Let's see, we don't need an extra n in there. Hypotenuse. So that's going to be our C. And so we can actually find the distance of these. Since we're dealing with units, let's just look at units. Okay, so A is going to be 1, 2, 3, 4, 5. Okay, so I'm going to say A equals 5. B is 1, 2, 3, 4, 5. All right, also 5. B equals 5. So I'm looking for C equals unknown, but let's plug it in. So A is 5, so 5 squared, plus B is 5, so 5 squared equals C squared. Well, 5 squared is 25, so 25 plus 25 equals C squared. Now I'm sitting here with 25 and 25, that's 50. So 50 equals C squared. Now, that means this whole thing is 50. That's 25, and that's 25. So what is this side length right here? Well, remember that the area of any square is just a side length times a side length. If I want to find just a side length, what I need to do is I need to take the square root, because that's going to be the inverse of the square root of each side, and that's going to say C equals the square root of 50, which we can just calculate real quick. We can take our calculator. We're going to hit the blue seconds, and then get that square root 50. It's going to be just a hair over 7, so it wasn't even close to that 5. Our answer is going to be A, 7.